Hello, everyone. Good evening. Myself, Jayesh Pamnani, as a host of the ICICT 20222. Dear authors and invited guests, welcome to the technical session 3C. On behalf of our Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are well aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in this unpredictable situation and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you will enjoy 2 days of the knowledgeable and interactive digital sessions. Also, there is a special note for the presenters. You will be given 10 to 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder and I request while the presentation is going on, the participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we start, I would like to introduce you all to the chairperson for the session, Cornelia Victoria Angel Drugain.
Hello, everyone. Thank you.
Thank you so much, ma'am. I will give a short brief information regarding the chairperson. The chairperson has obtained a license of engineering degree in computer science domain at Polytechnic Institute of Timisoara, Romania. Since 2001, she has a PhD in engineering in an automatic control domain at Polytechnic Institute of Timisoara. Thank you so much, ma'am, for chairing the session.
Thank you. Yes, thank you.
Now, I would like to start with the first paper, and I would like to invite the first author, Suhaib Ahmed, to present his paper on title Electronic Health Records Security and Access Control Using Blockchains and IPFS. I request you to please start your presentation and start sharing your screen.
Hello, can you hear me?
Yes, you are audible.
Okay, so I'm sharing my screen.
Yes, please.
The host disabled participant screen sharing. Can you enable it again? Is my screen visible?
Yes, it is.
Can you hear my sounds?
You are audible.
Yes, can you hear me?
Yes, you are audible.
Oh, can you hear the video?
It's perfectly clear. I would request you to please start your presentation.
France were attacked by hackers, causing some uncertainty. Hello, my name is Shoaib Ahmed, and today I will be presenting one of our research titled Electronic Health Records Security and Access Control Using Blockchain and IPFS. So, what is electronic health record? Electronic health records are electronic form of sensitive medical records, personal information, doctors provided prescriptions, and other physical histories of the patients. EHR system has remodeled the modern healthcare ecosystem but also increased many security and privacy concerns. So why does EHR need security? According to US Department of Justice, 10 individuals including hospital managers, laboratory owners, billers and recruiters were charged in 1.4 billion USD by rural hospital pass-through billing scheme. On February 2021, three hospitals in France were attacked by hackers, causing some surgical operation and some emergency patients shifted to nearby hospitals. Also in 2020, according to BBC, some hackers disabled the computer system of a German university hospital, causing a patient's death while being transferred to another hospital. These type of issues are increasing day by day around the world, so EHR needs to be more strong and secure and need more efficient access control system to prevent this type of incidents. So in our research contribution, based on our study, we proposed an architectural model of EHR system using IPFS and blockchain that is patient-centered, transparent and immutable with secure access control and accountability. Cost efficiency is key to our research. To make it happen, we have categorized data into two parts called payment data and health records, where large health record data are stored inside IPFS. We also proposed a systematic file architecture for IPFS. Then we analyzed some characteristics of blockchain transaction and the cost for storing data in blockchain compared to our proposed architecture to evaluate the cost efficiency of the proposed model. Finally, some approaches to optimize data size to reduce cost of our model. So our system is divided into three groups of participants. First, the owner of the record or patient whose data is stored in the blockchain and IPFS. Second, doctors or physician who will examine the patient, check and submit the medical record. Only they are allowed to store data. And finally, data questers including insurance companies, research and other institutions who are searching health data for ethical, legal or research purposes. In the system, each participant has two keys named public and private key. The patient has two extra keys called the access and the session key. These keys help the patient to control access of both blockchain and IPFS storage. Each participant also have digital certificates that are provided by an official certification authority to ensure the integrity of the user. We divided all the patient's data into two categories, payment data and health record. The payment data will be stored into the blockchain as it is text-based and cannot be erased or changed. These data includes bill for doctor's appointment, operations, treatment, hospital and medicines. Another data type is health-related data, which are mostly text and image-based. This type of data takes a lot of storage, so they are stored into IPFS to cut down the cost. This data covers every health relevant event such as surgical histories, medical encounters, immunization records, medications, demographics, etc. Finally, to achieve patient-centered access control, our proposed model of EHR uses three transactions of blockchain while using IPFS. These processes are divided into three segments. First is key generation and store. At first, patient register in the system and get an access key and session key. Then he encrypt using the patient's public key and store that access key into the blockchain to ensure integrity. Notably, patients only store and maintain the access key and the session key. So if revocation of keys is necessary, then the patient can generate new access key and use it to encrypt data again. The process is similar for the private key as well. Next up, data access. First, data receivers such as data quester or physician request access permission from the patients by sending their digital certificate attached with their public key. Patient then retrieves his previously encrypted access key, which are stored in blockchain. In our system, payment data and hashes of previous health record which are stored in IPFS are encrypted using cascade encryptions by physicians. Therefore, now patient decrypts it using the session key followed by the access key, and again patient encrypts this data using cascade encryptions, which is first by the access key and then with a complete completely new session key. Here, if the payment data is not required, then only the hash is encrypted. Now, patient encrypts the access key using the receiver's public key. And finally, all these data are stored in the blockchain. While these tasks are being done, from the patient's end, a one-time password, the required data address of IPFS and session key are encrypted using receiver's public key, and these encrypted data are sent to receivers through a secure channel. Now this data and access key which is retrieved from blockchain are decrypted by the receiver's private key. Therefore, receiver now has the access key, session key and OTP which are required to access. Now with the access key and session key, the previous medical records hash existing in IPFS is decrypted. Finally, receiver gets access to encrypt medical records stored in IPFS by providing the previous hash and the OTP, and the encrypted medical record can be decrypted using access and session key. Next one, data store. After getting data access, physician generate new data of patient. Then he uses the access key to encrypt the health records and store them in IPFS. This returns a new hash value of all records of IPFS. Then the payment data and the new hash value gets encrypted first by the access key and then by the session key. This cascade encryption ensures the access control of the patient and prevent physician to access the data in the future. After this, encrypted data are stored in blockchain. While storing data in the blockchain and IPFS, the physician digitally signs the data with his private key, guaranteeing the non-repudiation of storing data. In the future, to approve access for the data any receiver, the patient decrypts his encrypted data using the session key and generate a new session key. Using this new session key along with the other key, data are encrypted. Our health data record is stored into the IPFS. We organize the data by creating separate parent folder for each patient under the root folder of IPFS. The patient folder contains two child folders. One is for storing image-based data and another one is for storing text-based data. These data are arranged with the dates to keep track. It helps physicians to track and treat the patient more efficiently. In our cost characteristics, we analyze the cost for storing data in blockchain. For that reason, first we store 1 kilobyte of data 3 times consecutively. Next, data size is increased to 10 kilobyte and stored in blockchain again for 3 times consecutively, where data are different but equal in length. In this manner, we store data between 1 kilobyte to 70 kilobyte. We identify some special characteristics of execution cost and transaction cost, that is, if we store any data in the blockchain, and next, if we store the data larger than the previous data size, normally the execution cost and the transaction cost increases. But if the stored data size is equal to the previous one, then the execution cost reduces significantly, but the transaction cost remain the same. If we again store the data of same size, then both of the costs will remain the same. It is same for the rest of the consecutive transaction, or if their data lengths are equal. In our cost analysis, we used a simple smart contract to analyze the cost of data stored in the blockchain using Remix Ethereum IDE. In Ethereum, the cost is calculated by the amount of gas which is used for transaction and execution. Here, transaction costs are the amount of gas used for the base transaction. Execution cost varies from system to system depending on the smart contract. Here we store these data in IPFS through an API instead of blockchain. From the figures we see, storing 1 kilobyte of data in blockchain, the transaction cost is 58.41 USD, and if the next transaction is also 1 kilobyte, the execution cost is reduced to 20.24 USD and the transaction cost remain the same as previous. However, if we store data according to our model, then the first transaction is 6.82 USD, which is 83% lower than before, and the second transaction takes a total of 2.96 USD, which is 85% lower, and same for the rest of the transactions. So since each byte in blockchain is costly, we further tried to optimize our data. We analyzed a total of 401 titles of different diagnostic tests of 7044 bytes total. After two steps of optimization, 21.59% data is reduced. After first state, the gas total cost is reduced by a total of 8.73 USD, and after second step, reduced by 91.87 USD, which is 23.75% less than the initial cost. Moreover, instead of using full title of the test, a specific numeric code between 4 to 6 digits can be used for the specific test title. As our analysis, we find a title takes 16 characters on average. Therefore, representing them using numeric numbers can reduce the data size and save a lot more than our result. Finally, our key goal is to safeguard data access through patient's permission, but there might be some situations when patient is unable to grant access. How do we resolve this issue is still work in progress. Also, prices of cryptocurrencies fluctuate, which may raise a situation when per transaction fee becomes too high for the users. So we need to figure out a way to control the cost. Finally, we want to build a fully functional system for deployment. So these are the difficulties that we need to resolve. So that's all from us. Thank you so much for your time. These are the references. Thank you, and feel free to ask any questions. Hello.
Thank you so much, sir, for such a great presentation and informative presentation. I would request the chairperson, if you have any of the question for the presenter, please proceed further. As there's no response from the end, I would move to the next paper. And the paper title is A Low Cost and Energy Autonomous IoT Framework for Environmental Monitoring. And the co-author for this is Vasilius Galafagas. I would request you to please start sharing your screen and start the presentation.
Good afternoon. Can you hear me?
Yes, sir, you are audible.
Okay, thank you. I will share my screen now. Can you see my presentation?
Yes.
Okay, let's start. Good afternoon. My name is Vasilis Galafagas, and I am going to be the presenter instead of Professor Katsaros. This work concerns the creation of a Zigbee network of multi-sensor low power and energy independent nodes that use an IoT framework to monitor environmental data. Here in city of Volos, Greece, a few years ago, we had unfortunately phenomena of gaseous pollution due to the burning of woods and the extensive use of fireplaces to heat homes. This phenomenon, together with other environmental factors, greatly burdened the atmosphere. And this was the reason that led us to the implementation of a network of nodes which are able to measure carbon dioxide, microparticles PM2.5 and PM10, temperature, humidity, and luminosity as well. Here are the objectives we've set before and during our research. Firstly, we wanted our sensor nodes to be low powered and even better to be energy independent. Secondly, we designed a scalable wireless sensor network based on Zigbee with XP devices, which are low cost and can be low powered. Furthermore, we used multiple sensors, and that gave us the opportunity to test these sensors, their functionality and lifespan due to the repeated power downs. So we wanted also to improve their accuracy with applied filtering algorithms. We focus on an architectural design of an efficient, secure, and a scalable wireless network topology. That's why to connect the nodes and transmit the sensor data over the internet to an IoT platform using the well-known publish subscribe protocol. The IoT platform, as we will see, is based on open source solutions which stores the received time series data while providing also real-time dashboards to the users. We also evaluated the performance of the sensors by comparing them against the reference data from other stations, and we explore filtering methods to improve quality and accuracy. We had also issues concerning periods without data reception, like sensor node outage. And we addressed that with various prognostic algorithms, and we evaluated for forecasting purposes. Here you can see a diagram. It's a development and integration of a power supply circuit based on a solar panel, a lithium-ion battery, in order to maintain the energy autonomy of the wireless multi-sensor nodes. Each time sensor node measurements have been completed and the data has been sent to the router through network, a power timer IC was used to cut off power to sensor nodes. And this was to save energy. Of course, in order to achieve low power consumption, except for this, we had to make software algorithms and apply them periodically to force the XP module, sensor units, and also the Arduino MCU to enter sleep mode. We managed to reduce the power consumption 10 times less than we had measured it in the beginning. This is the implementation, as you can see, of one of the two wireless sensor nodes. We can see clearly the solar panel, the battery, the microparticle sensors, and along with the other sensors, the MCU and the XP device. This is the operational stages of the designed multi-sensor nodes. The Arduino MCU had to loop to sustain the power down mode to save energy. When entering the wake up mode, the MCU collects all sensor data and transmits them over the XP module to the corresponding destination, which was the router. The use of techniques that enabled sleep modes to the sensors, to the MCU and the XP device reduced the power consumption. At last, MCU triggers the timer circuit, which in turn switches off the multi-sensor node to reduce furthermore the power consumption. Here is the duty cycle. This duty cycle includes 3 operation states plus a 4th state in which the node is switched off. When a new duty cycle starts, when the power time circuit powers the node again, the capture current consumption analysis with within a duty cycle versus time is shown at this graph. let's talk about the sensor network. As we can see, each sensor node has to participate in a ZigBee network as an end device. For that reason, we have used and programmed the devices, the XP devices Series 2. The wireless sensor network topology incorporates the role of a router, which directly collects the data from sensor nodes and sends them to the gateway device. Network architecture was of a cluster tree network. Each multi-sensor node sends a data frame to the router consisting a concatenated string of the measurements and a predefined node ID to a specific router using its destination MAC address. The routers and the gateway were configured to keep alive their child MAC address for faster joint network, eliminating with this way the possibility of losing data packets. And of course, for security purposes, we enabled the encryption and device authentication in this wireless sensor network. Let's talk about the IoT platforms. The proposed IoT platform is based on a time series database that stores the received data, and as well as Node-RED and the Grafana, which are open source solutions for data processing and visualization. The gateway transforms the received XP data packet to an MQTT frame. And as we told you before, comprising a topic and the data. Then it sends this data packet via an SSL connection to the MQTT broker based on the well-known public subscribe protocol. This is the platform of Grafana. Generally, these platforms efficiently provide alerts and a private dashboard to end users like physicians or doctors or health authorities, and they can sync in with their secure accounts. Furthermore, we had to to implement a web page because we wanted citizens to have access to data visualization with this web page. Of course, we are talking about open data that can be accessed by every citizen, public service, or individuals, like we said before, doctors or people related to health, as their direct information is a priority for us and their protection. This is the evaluation of the sensor performance due to some sensor node outage periods. And in order to evaluate the effectiveness of forecasting algorithms, we performed data imputation by calculating the mean value per day and per node, and through merging the two time series from node 1 and node 2. We had also to perform linear interpolation to fit the curve of the merged mean temperature values. Furthermore, we have used daily moving mean values as input to the forecasting prediction algorithms like LSTM, Prophet, and Arimax.
Sorry for the interruption, sir. This is a gentle reminder that you have 2 minutes more for the presentation.
Thank you. Although data were generated from low-cost sensors, they were almost identical to the reference data and effectively captured the same temperature observations. It is deduced that we think it's very important to sustain adequate performance in an IoT framework like ours. So sensor nodes produce data efficiently without any gaps. And as a conclusion, I have to say that this current work presents an efficient way to measure air pollutants in a smart city environment and captures the microclimatic variations by using low-cost sensors and devices, as well as open-source IoT platform solutions. The utilized low-power techniques and energy autonomous mechanisms were described along with the overall low-cost IoT framework. Furthermore, we demonstrated how low-cost sensors can improve their performance and accuracy by employing filtering algorithms. In addition, forecasting algorithms were evaluated with prognostic efficiency on the sensor measurements, and we showed how multi-sensor nodes outages can be mitigated with proper data imputation from the other nodes, from neighbor nodes. And of course, future work could support mesh topologies and LoRaWAN wide area networks, along with machine learning techniques. Thank you. Thank you very much.
Thank you so much, sir, for such a knowledgeable information and the presentation. I would request the chairperson if she wants to proceed for the further questions of any of it. Let's begin with the third paper. The paper title is Use of Social Networks by Russian Politicians. And the author of the paper title is Anna Sosnovskaya. I would request the presenter, please start sharing your screen and start the presentation.
Yes, hello. Is it possible to share my screen? Yes, yes, it's possible. Yeah. And can you hear me?
Yeah, you are audible.
Audible. Thank you very much. Good evening. This is our research by Olga Gris and me, Anna Sosnovskaya. We are from Russia, and the presented results are just the beginning of a large study in the framework of actor network theory after Bruno Latour. We focus on related research questions. Can social media generally be viewed as an actor contributing to the development of democracy? What is the impact of social media on citizens and government? How do technical agents change the practice of network participants? Governments around the world are using social media as part of their governance. The Russian Federation government has introduced e-government plans since beginning of 2000. Use of social media started 3 or 4 years ago. Social media accounts are used by all or almost all Russian government leaders. We present the results of study of social media accounts of the 86 heads of the region of the Russian Federation for period January-May 2021 and survey of 54 government officials for the period August-November 2021. There are 3 actors of the network under study that have agency. Government treats communication as a way of unidirectional information and control in most cases, while citizens treat it as a accountable and transparent channel of representative and the opportunity to give feedback on their activities. The platform itself pushes users toward a more horizontal manner of association, offering constantly updated algorithms, tools, and rules. Understanding this dynamic is only possible when we recognize the agency of the platform in shaping discourse. An actor network style of explanation after Bruno Latour helps us keep abreast of ever-changing and redefining practices and conditions to describe network reassembly and emerging associations. In the course of our research, we asked the following questions. How does this network function? What are the problems in communication? What are coping strategies? What are concepts, interests, goals, assumptions, values? The choice of the accounts of the heads of region for analysis is due to the fact that they are a central media person representing the image of power among the population. We analyze the qualitative and quantitative characteristics of social networks of the heads of region to gauge how effectively they are being used. Analysis of all social networks used showed that the heads of region use Instagram accounts as the main ones. We have reconstructed the set of functions used in all communicative strategies, ranking them and counting them, and count how many features each account uses. The second number in this table is the percentage of accounts that use this feature in their communication strategy. All strategies are assigned to one of three communication styles: unidirectional, bidirectional, or interactive. Clustering and codification of statements made it possible to distinguish 403 semantic units on 7 topics. The results of codifications and interpretation of the data obtained are presented in the table 2. This is just a part of big table 2. Semantic units are illustrated with verbal examples from accounts. There is usage percentage in accounts. Interpretation is an assignment to one of 3 types of communication already mentioned. We also referred these semantic sets to horizontal or vertical communication. By vertical communication, we mean communication used in the system of power relations, where one subject of communication has certain resources for decision making. All respondents note that social networks are primarily a tool for informing and feedback. For the most part, respondents state that it's controversial at the moment to introduce social networks into the formation of a positive image of leader or government body. Only 15% of respondents describe social networks as a tool for forming a positive image of authority as a leader. Although Instagram considers such user with such a large number of followers as an influence, offering promotion and influence tools. According to our respondents, citizens use social networks as a channel for conveying certain problems to the authority. However, according to respondents, they are used to an even great extent to express negative emotions about the activities of the authorities. Thanks to research, a high level of dysfunction in the implementation of vertical communication was revealed when using horizontal communication of social networks. Many statements indicate the unwillingness of the authorities themselves to cope with the flow of information. These statements are confirmed by the results of our previous research of the need to form information and communication competency among civil servants. We expect more transparency and horizontal governance due to the influence of social networks and their use by citizens and government's leader. We expect social media to reshape government-citizen interactions into satisfying horizontal connection. Those who do not recognize will remain on the periphery. Who do not reorganize will remain on the periphery of the discourse and managerial articulation. researchers have investigated the conditions of the emergence of certain strategy using the concept of affordance used in the field theory and actor network theory. The concept of affordance arose from the study of the interaction between actors and their environment. This point of view implies that several possibilities of the same object may arise in connection with different points of view of the actor. Thus, for example, it's possible not to be aware of Instagram possibilities. For example, the main omission in all accounts is the non-use of geotags. Since Instagram maps the interest and movements of user, such metadata could be used in urban planning process. Three aspects of communication suggest themselves as a target for future study in terms of affordance by social media platform actors. First, there are no interaction in the account. Interactive communication would be only achieved if the government and the leaders see themselves as a part of the network and recognize that many actors on the network have valuable information that can be contributed to governance. Second, officials who listen to citizens on social media need to have a high degree of openness, respect for difference, and reflexivity, which translates into personalized images. Heads of region can claim to be influence among citizens, which, although they are instrument of different ideological commercial platform, can lead to civic participation in government. Third, all researched accounts were subject to criticism, attacks, and negative hate. Each leader choose one of few strategies for working with the negative, either comment, ignore, or delete. Researchers have noted that social media is a private business that unconsciously enforces its own rules on offensive language, confusing the problem and making it difficult to solve. There is no complete clarity in the communication strategy of technical agents. Researchers have suggested centralized control over the internet space and social networks, either the establishment of government control or the regulation of social media as public enterprises. One opinion would be to proactively moderate social media posts where people are essentially earning the right to good behavior rather than the current practice of pre-moderation. Another idea is random moderation, in which people are encouraged to behave because they do not know when their comment can be viewed, like a virtual panopticon, as described by Foucault. A third option would be the creation of level of participation with different obligation and different standards of removal, including the permanent ban. Regardless of the method used to combat harassment or of politician on social media, it's clearly important that platforms act quickly and consistently to enforce their own rules against offensive language. Thus, we analyze the features of communication, problems, strategy, practices, interests, desires, goals of three actors: heads of regions, citizens, subscribers of accounts, social media. We welcome questions and a recommendation for further our exploration of these networks of relationships. Thank you very much.
Thank you so much for the great presentation. I would request the EXA chairperson, if she has any of the question for the presenter, please proceed.
Sorry, can you say it again, please? I'd like to stop presentation. Say it again, please.
If the chair...
Yes. Cornelia.
Yes, thank you. This is an interesting domain. I also have a course of e-government in Romania. And social media. We have a workshop with social media and interactions.
Mhm.
Congratulations for the paper.
Cornelia, thank you very much. Is it possible to connect somehow to maybe to join
Yes.
your workshop?
Yes,
maybe.
sure. I will be great to invite you. It's a honor for us.
Thank you, Cornelia. Could you please write your email in the chat if
Yes.
possible? Thank you very much.
Yes, of course. Yes, of
Thank
course.
you very much.
Thank you.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you so much, the chairperson and the author. I would
Thank
represent
you.
the next. I would like to
Thank you.
invite the next paper title, Factors Affecting Intelligent Enterprises Resources Planning System Migrations, the South Africa Customer Perspective. And the name of the author is Precious Mushai. I would request you to please start your presentation and share your screen.
Thank you. Good day, everyone. My name is Precious Mushai, and I'll be sharing my screen. Okay, our topic, our research topic is entitled Factors Affecting Intelligent Enterprise Resource Planning System Migrations, the South African Customer's Perspective. As I mentioned before, my name is Precious Mushai, and I'm here representing my co-author as well, Dr. Tembekile Mayayise, and we are from the University of Witwatersrand here in Johannesburg. Today, my agenda is just to take you through a background of our research and to discuss our research question and the research methodology that we followed, as well as to outline the findings that came out of our research and to leave time for any questions. So as we know, we are currently in an era of digital transformation where we are seeing revolutionary technologies such as artificial intelligence, blockchain, cloud computing, machine learning, and Internet of Things. These technologies are impacting our lives on a day-to-day basis. Now, these technologies are not only impacting us as individuals, but are also impacting the way that businesses are run, as well as the systems that help businesses do what they need to do on a day-to-day basis. Enterprise resource planning systems, such as SAP's ECC 6.0 and Oracle's e-business suite have had to evolve to become intelligent ERPs, namely SAP S4HANA and Oracle ERP Cloud, in order to adapt to the changes in this era of digital disruption. Now, as most ERP customers would know, ERP implementations have been dogged with negative reputations. They have been known to be costly. They have been known to be failures some of the times. So this has given the ERP systems a generally negative reputation, as they are also costly implementations. Now, with the introduction of intelligent ERPs, clients have been forced or are being recommended to move on to intelligent ERPs. And this is a complex decision for most customers, specifically for those customers who are in developing countries such as South Africa, where the readiness for these revolutionary technologies and intelligent ERPs might be behind that of developed countries. So this background set us up for our research question to find out what are the factors that determine whether or not organizations in developing countries such as South Africa will migrate to the new ERP versions that have been introduced by ERP vendors. We wanted to find out what are those key determining factors for our research subjects to adopt or not adopt the intelligent ERP systems. So the study was based on a research model, which was based on a combination of two theoretical frameworks, namely the TOE framework, which is the technological, organizational, and environmental framework. And we combined this framework with with the institutional theory, which speaks of coercive forces, mimetic pressures, normative pressures, and how these impact adoption decisions by organization. As you can see, in each of these three contexts, we were looking at different factors that we hypothesized would be a determining factor for the adoption of intelligent ERP. So I'll take us through the hypotheses that we proposed. Within the technological context, we proposed that the access to ICT infrastructure, the availability of cybersecurity systems, and the availability of technical skills are positively related to intelligent ERP adoption. From an organizational context, we proposed that the size of an organization and top management support are positively related to intelligent ERP adoption. And from an environmental context, we hypothesized that coercive forces, mimetic pressure, normative pressure, and increased regulations were also positively related to intelligent ERP adoption. So these were our 9 hypotheses that we proposed, and we tested these in our study. The study was done through a questionnaire which was sent to 95 South African SAP customer organizations. The questionnaire was administered via Question Pro, which is an online website. And the questionnaire had 2 sections. One was valid for those who have already adopted SAP S/4HANA, and the other section was only to be populated by those who had yet to adopt SAP S/4HANA, or those who said they are not going to adopt it in the near future. The questionnaire was also built on a 7-point Likert square, which the respondents had to respond to. Our results were split into the results for the adopters and the non-adopters of SAP S/4HANA, and these are shown on the screen. You can see that for some of these hypotheses, it was accepted for both adopters and non-adopters, and it was rejected in some cases. However, we did have 4 hypotheses which were accepted for both adopters and non-adopters, and I will discuss this. We came to the conclusion that access to ICT infrastructure within the South African environment is positively related to intelligent ERP adoption. Availability of cybersecurity system was also confirmed as a factor by both adopters and non-adopters. Mimetic pressure was also confirmed as a factor for adoption, and normative pressure was also confirmed by both adopters and non-adopters. So these results show us where the South African landscape is in terms of intelligent ERP adoption. We also had interesting findings from this research, one of them being that only 26% of the respondents confirmed that their organizations had migrated to the new ERP version, which implies that the adoption of intelligent ERPs in South Africa is still in its infancy. And this is quite concerning, as South Africa is one of the more advanced of the developing nations here in Africa. And also from a technological advancement perspective, it was quite encouraging to see that of those who had adopted intelligent ERP, 59% of these had adopted cloud computing as their deployment option for their intelligent ERP, whether it had been a hybrid deployment or a public or private cloud deployment. Those who are jumping onto the intelligent ERP bandwagon are willing to embrace advanced technologies such as cloud computing. And I think this does give this gives us confidence that there is room for intelligent ERP adoption and the room for adoption of other advanced technologies within the South African environment. Okay, that brings me to the end of my presentation. I'll leave room to any questions.
Thank you so much for such a presentation. I would request a chairperson, if you would have any of the question for the author, please proceed for the question. As there's no questions, we would be moving to the next paper title. The paper title is Quality Management within the Visiting E-Culture Tourist Destinations. Case study, rural parish of San Miguelito. The paper author is, the name of the paper author is Alicia Porras Angela. I would request you to please start your presentation and share your screen.
Hi, everybody. Can I share the screen, please?
Yes, ma'am, please.
So good afternoon, everybody. Can you see my screen?
It's not visible, right?
Can you see my screen?
Can you please start sharing your screen once again?
Hello, everybody. I don't know if you can see my screen.
No.
Hello. I think that I'm having a little bit of technical problems, so I'm going to ask another colleague to project my slides, and I will be using another device in order to present this. Also, please, Alba, are you there?
Yeah, ma'am.
I think, let me check. So sorry. Now I'm again here. Yes. Can you see my screen?
Not yet. Yes, it's visible now.
Hi, everybody. Can you see my screen?
Yes, it is. I would request you to please start with the presentation.
Yes. Can I start?
Yes, please.
Okay. So good afternoon, everybody. So much for the invitation. And well, I am from Ecuador, and the topic presented is quality management within and visiting e-cultural destinations, case study rural parish, San Miguelito. So this is the outline that is going to be presented. In the first part, our visit site in this rural parish in San Miguelito, it involves some factors, which two. The first one is the destruction of historical sites, and the second one is the limited development of tourist activities. That is because of the low influx to cultural sites. Those components are the ones that are directly that affect the progressive loss of cultural identity. And with that representation in sites narrate the beginning of Kosanga Piliero culture, using a cultural sites that involves a loose portion of the history. Of course, that all of these, according to Garcia 2015, He mentions that planning and organizing the pressure that civilization exerts visiting and cultural sites when participating. Another principal thing to talk about quality management is the cultural sites that constitute process in future that will contribute integral sustainability through the application of the correlation methodology, which this is articulated with a quality factor at the sustainability of the cultural destination. And what are tourist destinations? They are connected with the natural, also with the cultural environment. Both integrate the community here. And what generates strategies, or what is based on when exist needs of people in visiting cultural sites through four important aspects. The first is the quality of program that they provide to people. Then the process of management applied in this type of attractions that Pijaro has nowadays. Also balancing the cultural sustainability that those places have. And finally, the social of residents and the tourist. Also in the tourist management, I can say, according to these authors, Solano, Beatriz, and Marquez 2016, is a dynamic
So sorry, I think that I had technical problems with my internet. I don't know if it is possible to continue sharing with another screen, please. Yes, thank you so much. Please, can you put in the slide that says tourism satisfaction? Go to the next slide, please. Next slide. Thank you. Next slide, please. Thank you. Over there. Thank you so much. So as I was telling you here, the tourist satisfaction plays an important role, and that is because of the expectations and the satisfactions that they have. Next slide, please. Next slide. Now, let's talk about a little bit about the quality. It's a fundamental piece of services, and also how the goods and the products we take it. So that is what this author say, that who perfected the theories of quality based of improvement of the products and goods and services. And something that was important to analyze in this research was a model that is a complex structure, which allows determining aspects such as the planning, the control, the systematization of how they plan, and also the operation of tourist processes. Next slide, please. And well, here talking about the service performance model, this was something that we use in our research in order to evaluate the perception of the quality and satisfaction on similar aspects that has been used. This permitted us to know the qualitative research in a dimension in services, in museums, and also in taking peculiarities with cultural visit sites. And this service performance model presents indicators based on quality, satisfaction, and intention to recommend an effective learning with people. So next slide, please. Here, talking about the quality of management. As you can see, we work in this figure with some parameters. The first parameter talks about how it has to be applied. It has to be applied to all the processes that make up in a management system. Also, how to take as a central objective to achieve the goals that we are planning in our agenda, or the things that we are proposing to have better results. And the next part also, the next parameter is the participation of the staff who make up of the organization, and also is very essential in this part. And finally, is the participation objective that achieve continuous improvement in effective process control system. The next slide, please. And something that also we were analyzing is the ISO 9001, that is the family of norms that does not determine the standards or criteria of the service. But talking on the other hand of the Q certificate includes all the standards and it specifies that we can apply in our research. Next slide, please. Now, the visiting cultural sites also determine the visited cultural sites within the classification of cultural tourism. As I said before, we identify the museums, the monuments, and also historical sites. And what was the main objective here was to present the history, the art that Píllaro has, and also the culture of the destination. And frame of all of these, it can be said that they are places where tourists can interact with the history, with folkloric and essence of the community. Next slide, please. Now, let's move on to the methodology. This study is a correlational and descriptive type. The detail of the phenomena influenced the visiting cultural tourist destinations. And also, it is a determining factor in quality, the perception of quality through the satisfaction categories that can be defined. It was focused on the Likert scale, which allows us to know the quantitative definition on the difference between the variables of quality management in visiting cultural centers. And finally, it measures real values and not values. And where we could study here the Pearson correlation coefficient that will be elaborated because the variables are distributed approximately from one to another, to avoid taking outliers. And finally, to define the correlation that was significant, if the correlation is significant in relation to the verification of the variables and the hypotheses. Next slide, please. Here, the model that we use was the service performance, which it has been found empirical superior to Serpol scale to be able to explain greater the variance of the total of quality. Here, the population that we work with this model, we consider here the numbers first, the number of tourists and also visiting cultural sites in museums, in monuments with registration and historical sites. The total of visitors were 873, and we work with Gobierno Autónomo Descentralizado of Santiago de Píllaro, and also with Gobierno Autónomo Descentralizado Parroquial de San Miguelito. Next slide, please. In the results, we can say that here, according to these figures, in the first figure, you can see that the two variables, according to the instrument that we applied in quality management and tourist satisfaction, provides the results in the Cronbach's alpha of 0.8, which indicates a good level of reliability. Consider that is less than 8. And on the other side, you can see the non-parametric correlation that are the results that have to measure with a 0.7 of 10, demonstrated that it is a positive relation with the data which determines the level of cohesion of the management and quality. Next slide, please.
Sorry for the interruption. This is to remind you that you have 2 more minutes to go.
Thank you so much. Okay, so here, can you put a slide, please? Hello? Okay. And
Yes, thank you.
okay, so yeah, I'm trying to finish. Okay, so please can you go to the next part? Just I want to show you here in this part, you can see that the alternative hypothesis, it was accepted according to what we found in this research. And the next slide, please. Next slide, please. Here, as you can see, we can say that our research plays an important role because we could analyze the quality of management in the satisfaction of tourists visiting cultural tourist destinations. And what happened with them? They potentiate tourism at the national and international level since the services offered are of quality. Thank you so much. If you have any questions, thank you.
Thank you so much, ma'am, for the presentation. I would like to invite the chairperson if any of the question needs to be asked to the author.
Excuse me. Excuse me, can you repeat, please?
If any of the question needs to be asked from the chairperson, I would request the chairperson to ask the author any of the questions if needed. I believe that no questions to be asked. Now moving on to the next paper title, we have transferability of quantum adversarial machine learning. And the name of the author is Vincent Lee. I would request the presenter to please share sharing your screen and start the presentation.
All right, can you see my screen?
Yes, it's clear.
Great. So, hey everyone, today I'd like to talk about our project on the transferability of quantum adversarial machine learning. My name is Vincent Lee, and I did this project with Tyler Wooldridge and Xiaodi Wang. So first, I'd like to give you all an outline of what the presentation is going to look like. So first, I'm going to go through an introduction of the project, and then I'll talk for a bit about quantum computing and adversarial machine learning. And then I'll discuss the experimental results, and finally, the discussion, conclusion, and future research directions. So to give you an introduction of the project, this project was motivated by quantum supremacy. So the attainment of, or the fact that quantum computers could do things that classical computers couldn't. And we also see it as an extension of the work of Liu et al. In 2020 on adversarial machine learning and the transfer attack. In this project, we investigate whether an attack on a quantum neural network can transfer to other neural networks, whether those other neural networks are classical or quantum. And so in particular, we use the MNIST dataset, and we use Python and Google Colab for the code. To give you an idea of what the research process looked like, what we first did was we designed the quantum neural networks, and then we trained those neural networks. And then we took the gradients with respect to the white box quantum neural network to be able to perform the adversarial attack, and then conducted experiments on adversarial machine learning and the transfer attack. And finally, we measured the effectiveness of the transfer attack on the other neural networks. So now for a bit about quantum computing. So one of the main differences between classical and quantum computation is that classical computers use classical bits, which are limited to only two states, 0 or 1. So there are only a very limited number of operations that you can do. On the other hand, with qubits or quantum bits, they can do a whole lot more than classical bits. So they can go into superposition or be rotated around the X, Y, and Z axes, or they can become entangled, for example, which gives them a lot more freedom in what they can do. So here's what the classical neural networks that we use in the project look like. And so you can see they kind of have that general input hidden layer and then output layer sort of structure. And while they may have differed in some ways, for example, in the number of neurons or number of hidden layers from this diagram, they overall follow this, the same general structure. Here's what the quantum neural network looked like. And the design that we used was inspired by the TensorFlow developers in 2021. And so what we did was we had data qubits. So we actually had a total of 16 rather than 2, but we only showed 2 here for simplicity. And these data qubits are those that take in the input image from the MNIST dataset. And we then have a readout qubit that reads out the results. So we really only need 1 readout qubit because we filtered the 10 classes of the MNIST dataset into 2 classes for simplicity. And so first we prepare the readout qubit by passing it through an X and an H gate. And then we have this structure with this X gate applied to the first data qubit and the readout qubit. And then we raise that to the power of XX naught. So that's just the parameter that the neural network learns through training. And then we do the same thing with the second data qubit and the readout qubit. And then again, we raise that gate to the power of XX1. So again, the neural network ends up learning what the optimal power is. Then if we sort of repeat that with the rest of the data qubits, and then we repeat that sort of similar layer structure with Z gates and with C naught gates. And finally, we have an H gate at the end to take the readout out of superposition. And so that's in general what the structure of the quantum neural network looks like. So now I'd like to talk for a bit about adversarial machine learning, which is the study of vulnerabilities of machine learning algorithms. And it analyzes how data can be altered so as to fool algorithms into misclassifying that data. In our case, these adversarial examples are just images that are capable of causing misclassification of the neural networks, even if they're similar to non-adversarial images. So in particular, the adversarial attack method that we used was the fast gradient sign attack, which was introduced by Goodfellow et al. In 2015. And that's described by the equation that you can see here. So X adversarial is a vector representing the adversarial image, and that's just equal to X, which is the original image, plus this noise term here. And so to describe it, I'll go from the inside out. So this J function is really the cost function that's associated with the original image, the model, and the actual label of that image. And then we take the gradient with respect to the image of that cost function. Then we take the sign of each of those components of that gradient and we multiply it by this epsilon term here. So epsilon is really just a scaling constant that describes the intensity of that noise that we then add on to the original image to create that adversarial image. One of the differences between what we did and what Goodfellow et al. Did in 2015 is that we apply this attack to the PCA components of the images directly rather than to the images themselves, which saves us a great deal of computational time. So to give you an idea of what the images look like, on the left, we have an original image from the data set. And then the next image after that is what it looks like after PCA. And then the next image is then with epsilon equals 0.4. So that's after it's been attacked. And then after that, you can see it's epsilon equals 0.8. So you can see in each case, as epsilon increases, the images become more different from what it looks like after PCA. So this is what the transfer attack looks like. So we first perform the fast gradient sign attack on the white box quantum neural network. And then we take the images that are the adversarial images that are produced as a result of that attack and use those to attack the other three neural networks that we used in this study. So the black box quantum neural network and the small and large classical neural networks. And so with that said, I'd now like to go into the results of this experiment. So with the fast gradient sign attack, what you can see here is that when epsilon is 0, so basically the images are the same as well, the original images, then you can see that the accuracy is quite high, but then as epsilon increases, the accuracy decreases up until epsilon equals 0.4. And then as epsilon increases from then, the accuracy then increases back again. So another way of representing these results is with confusion matrices. And so I've colored these and orange, the orange cells are those for which a lot of the samples fit that description. So in short, what this really is, if we look at the confusion matrix on the top, is that the fact that the oranges are on the main diagonal of the confusion matrix really implies that the model made a lot of correct predictions. On the other hand, if we look at the bottom confusion matrix, the fact that the oranges are off the main diagonal means that it made a lot of incorrect predictions, which is exactly what we'd expect based on the accuracies. And then when epsilon equals 0.8, again, the oranges are back on the main diagonal. So that means that the model made a lot of correct predictions. So with the transfer attack, here's what it looked like. I already went over the blue curve, but the red curve is the black box quantum neural network. And the green and yellow curves are the large and small classical neural networks respectively. And so you can see that as epsilon increases from 0 to 1 with all of these, you can see that the accuracy ends up decreasing from a very high level to something that ultimately bottoms out. And it's a different value for each of these neural networks. So interestingly enough, if we look at the confusion matrices, this is what they all look like. So you can see with three of these four, the oranges are actually on the right side. So what that implies is that for the actual positives, the transfer attack was able to cause the models to misclassify them as negatives. Whereas with the actual negatives, the model actually got them to have a correct prediction. It's interesting because if you look in the bottom right for the white box quantum neural network, that's actually not the case. It just incorrectly predicts everything instead of incorrectly just predicting the actual positives. So to summarize the results, what we've done is we've made a bar graph of the maximum transferability ratio for each classifier, which is the maximum proportion of images across all values of epsilon for which the transfer attack was able to cause misclassification in all of these neural networks. And you can see with both quantum neural networks, the maximum transferability ratio is well above 75%. Whereas with both classical neural networks, it's a bit lower, but you can still see that it's clearly above 50%, which shows, again, that the transfer attack is indeed effective. So to summarize the contributions of this study, what we first did was we designed the quantum neural networks based on the design of the TensorFlow developers in 2021. Second, we modified the fast gradient time attack to deal with the reduced computational capacity. So that's the thing with directly modifying the PCA components rather than the images themselves. Third, we tested the transferability from quantum rather than classical neural networks. And in doing so, we extended the work of Liu et al. In 2020. And fourth, we showed that the fast gradient time attack applied to the white box quantum neural network does indeed transfer to the other neural networks, which implies that there is a transferability of the adversarial attacks on the quantum neural networks. What's also interesting is that the vulnerability of the actual positives to the transfer attack suggests that the models in general may be more prone to misclassifying actual positives, which is interesting, and maybe because the models have very similar decision boundaries that cause them to have that kind of similar vulnerability. So in terms of the directions of future research that we could possibly take, one direction is defense, because in terms of defending, the similarity of the decision boundaries could be defended against by creating an ensemble of models with intentionally different decision boundaries, which will get rid of that issue with the similar decision boundaries. Another interesting technique that could be used is wavelet denoising. In terms of applications, one idea is to use this transferability in order to conduct black box attacks on quantum or classical models by creating a quantum neural network and then using that to create an adversarial data set. In terms of extensions, future research could extend the study by assessing whether these results hold across other model types. So for example, support vector machines or decision trees, or other kinds of white box attacks, or other data sets other than MNIST. And on the theoretical side, a better understanding of the weaknesses of these models can lead to better models which can overcome these shortcomings. So thank you for your attention.
Thank you so much, sir. I would request the chairperson if any of the questions for the author. I believe that that's the end of the presentation. I sincerely thank our author for the excellent presentation contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publications will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. I also thank our session chair, Cornelia Victoria Angel Druberin, for chairing the session. I would request a token of appreciation to the chair on behalf of the team ICICT 2022 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am. I would request the chairperson to say some words for the presenters and the authors.
Thank you very much. That was great to invite me to be session chair of this conference. The articles are very interesting. The domains are very actually, and I'm very glad to hear the articles.
Thank you for your valuable presence. Now,
Thank you very much to all.
Dear all, I kindly request all to switch on the cameras for a quick snapshot of the virtual conference for a memory. Thank you so much. Stay safe and take care. Thank you.
Thank you. Take care. Thank you. Bye-bye.
ce faci, doamna? Ești invitat la București, conferență dată de pace